Hey 8th graders, these are going to be our introduction to matter notes. So first I'm going to talk about Cornell notes and what I'll be expecting of you with Cornell notes, and then we're going to take the notes on Cornell note paper. I don't always use Cornell note paper, especially if we're just doing vocabulary, but I really do like the Cornell note style. Alright, here is a picture of Cornell notes. So this is an AVID strategy, and as you know, we are trying to be an AVID site school-wide. So it's set up on the top with the topic or objective. So for this, what we're talking about right now, our unit is matter. So you could just write matter. This is really bad. Okay, name, class period, date. This will be taped in your notebook, so this isn't as important. The essential question is what the notes are trying to answer in the end. Normally, when you take these notes, they aren't structured, everything is for you. So I'm going to be giving you almost everything, and then later towards the year, you'll be doing the questions on your own. So normally for this notes here, you go through and you write the notes, the key ideas, the thing that you should know is that you're not writing everything word for word here in the notes. You're just writing the things that are important. And if you have any abbreviations, or if you write and, that's how I write my and sign, or if you write and, if you write with, or between, I can't think of any other abbreviations, but you abbreviate the notes so you're not writing everything word for word down. And then after you take the notes, you're supposed to do the questions. So this would be either the key ideas that go with the notes for each piece, or it could be the vocab word. I like to frame them as questions though. So first you take your notes, then you write down your questions after you take the notes, and you try to figure out what is important. And then the last thing is the summary, and I do require you to write a really good summary after we take notes. So the summary is 3 to 5 full complete sentences. Okay, so you're restating all the stuff that you just learned in these notes in your own way. So you're not just rewriting everything that you already wrote down in the same words. You are thinking about it in a different way and making connections between the different pieces, and then you're writing about it and making connections down here in the summary. So don't start the summary with, today we talked about matter. The notes today were about matter. Today we learned about the characteristics of matter. The topic today was matter. So you're not writing just like a fluff sentence that doesn't mean anything. You're writing actual things here in your own words. So making connections between the examples and the definitions, or just putting it in your own words. Alright, so today we're going to take our notes on matter introduction. This is really all about the whole unit, and it's just to give you a brief overview of all the different things for the next couple of weeks. You can either choose this one that is the bare bones, or you can choose this one. You will be taking a picture of your notes and uploading them to Schoology, so if I see that you are perfectly capable and you chose this one, I'm probably going to come talk to you about that, because a lot of you are totally capable of doing this and writing everything in here and being organized. I've already given you half of this stuff. This one is for maybe slow writers, ELLs, or if you're not sure how the Cornell note works so far. But if you are totally capable, please use this one. Alright, here's the top. I believe there are six or seven questions to these notes. The first question is, what is matter? Matter is anything that has mass and takes up space. So anything you can see, anything, even air, that you can't see, is matter. It's made up of atoms. Everything has mass, except for like thoughts or the pictures that you see like coming from a screen. Feelings, that's not matter, because it doesn't take up space. It's just in your head and it's just what you're thinking about. Number 2, what is mass? Mass is the amount of material in an object. Mass is measured with a balance or a scale. Electronic balances are easier, but there are balances that you put actual weights on and you try to figure out what the mass is. Mass is different from weight, and you'll watch a video about the difference between mass and weight, but mass is the amount of the material in the object. Weight is the mass and the gravity that is exerted on you when I'm standing on Earth or anywhere. So here on Earth, there's a lot more gravity, so I weigh more, but my mass is the same as when I am on the moon, because I have the same amount of stuff that makes up my body, but it depends on the gravity. Okay? And if at any time you need to stop this and write all this down, or if you want to reverse it, that's what's great about videos. You can stop it and do it at your own pace. Number 3, what is volume? Volume is the amount of space something takes up. So I take up space. I could be put into a pool and the pool water might rise a little bit because I do have volume and I'm displacing that water that I am in. So the water level might go up. Kind of like when you have a glass of water and you put your ice cubes in there, the water level rises because the ice has volume and it's taking up space in the glass, so it's moving the water up. Okay? So it's the amount of space something takes up. Volume is measured with a graduated cylinder. Okay, here's a picture of an electronic balance or a scale, and this is how you measure the mass. This does not take into account gravity. We're just figuring out how much stuff is inside something. Volume, this is a picture of a graduated cylinder. We will be using these. We measure in milliliters, and that's how much liquid it takes up. You could also do this with solids, and you put something in here and then the water level will rise and you'll see the difference between, that's the volume. So how much space something takes up versus how much stuff is in an object. Alright, number 4 and number 5. These are talking about properties. A property describes something. So it's kind of like a characteristic. So I would actually probably say property is the same as a characteristic. It tells you something about something. So if you were trying to describe somebody, you would say characters or characteristic. Characteristic. Anything that describes something. And there are 2 different types of ways to describe all matter. There are physical and there are chemical. So number 4 is, what are physical properties? These are ways that you describe something that you can see with your eyes. So you're not testing it, you're just looking at it, measuring it, feeling it, and then making up, or not making up, but describing the matter based on that without changing anything about it. Okay, so all matter has physical properties. Physical properties can be observed without changing the substance. Examples: I can measure the boiling point, I can measure the shape, or I can look at the shape, I can measure the density, I can look at the color without changing it, and I can smell it. So these are really using your senses. And I'm sure you learned all about density when you were in 6th grade. Density is how much stuff is packed in to a certain amount of space. So you have to have the mass and the volume. And this is how you calculate it. So mass over volume. So how much stuff is inside something and how much space that thing takes up. So when you're comparing a marble to a ping pong ball, they could probably be the same size, but the marble would be more dense. A ping pong ball it's just air inside, so that doesn't weigh a whole lot, or it doesn't have a whole lot of mass. Okay, a chemical property, number 5. All matter has chemical properties. Chemical properties describe a substance's ability to change. And when it changes into a brand new substance. So we're actually changing the matter and trying to figure out properties about it. So if I add something to it, I could make it rust. I can never get a brand new bike back when it's already rusted. I could buff the rust off, but I could not get all of my bike back because some of the metal on it has corroded and it's now a new substance. Okay, I could measure the reactivity, I could light it on fire, I could explode it. I could never get that thing back when it's broken into a million pieces and fried. So examples are reactivity, rust. If something creates a gas, then some of the matter is breaking up into a new substance. And some of it might change, but you might just release the gas. But anytime you see gas, you are changing it. Or when I start something on fire. So when I have a bonfire and you throw your wood in there, you can never get that wood back. That is a chemical property. All right, here is the last question for our Cornell notes today. If you are using the bare bones notes that doesn't have all of this stuff in there, you can use the back or on the notebook page that we're going to be folding and taping this to. So you might be writing bigger than this font. Okay, this standard we're going to be talking about pure substances. The next standard that we're going to be moving on to is about mixtures. A pure substance is matter that cannot be separated any further into other parts. It's pure. There's nothing else in this thing that you could break it up into. So examples would be oxygen, and don't confuse oxygen with air. Air is a mixture, a gas mixture of a bunch of different stuff, and oxygen is only 30% of the air that you breathe, and our bodies are just really good at taking the oxygen out of air. But you could have smoke in the air, you can have small pieces of metal that are floating around, helium, nitrogen is a big thing. So it is a mixture. Oxygen is not the same thing as air. Pure water, this is different from tap water. Tap water is a mixture of stuff because in the pipes, stuff comes out of the pipes, and then when you get it out of the ground, it could have dirt in it, it could have, we put fluorine in our tap water, it could have arsenic or anything that's really bad for us, and that's why we have water treatment plants that clean it out. But pure water is after it's distilled and evaporated. This is all H2O. Oxygen is oxygen with just an O, and as a gas, it's 2 oxygens. So I cannot break anything that's pure up into any other parts. A mixture is a combination of 2 or more substances. So a mixture would be like air. A mixture would be salt water. I could take the salt out of the water. I could take the fluorine out of the water. I could take all of the gross stuff off of pizza that I don't like. That's a mixture. Okay? So on here, matter that is a combination of 2 or more substances that can be separated. So pure cannot be separated, mixtures can be separated, and we will be practicing taking mixtures apart. Okay? If you are confused or if you want to go back and listen to this again, you can totally do that. After you read through it one more time, you need to write a summary. Your summary needs to be between 3 and 5 complete sentences. It needs to be in your own words. Don't just regurgitate everything I said. So you don't make a sentence and say a pure substance is matter that cannot be separated any further into other parts. You already wrote that. Write it in a different way. Give a couple more examples of something that cannot be broken apart. You're going to go back and use all of the questions here, not just number 6. So you're going to write about matter. What is volume? What is mass? How do I measure it? You could write about physical properties or chemical properties, something that can be observed without changing the substance or something that's observed with changing the substance and you can't get it back, or a pure substance or a mixture.